right, hi, live, Paley Basement Studios. We're up to remote learning number 6. This is Wednesday morning. Hello all, hopefully all is well. Today we're going to focus on matched pairs, which, you'll see, some of you have reached out to me about the last assignment, the 2-sample t-test, which is comparing or seeing if there's a significant difference in averages. So you have like 2 sets of data. We had a sleep score for before and after, and I was really thinking about the after set of data would have on average been higher. I was thinking more people would be sleeping better due to the lack of schedule and not having to wake up for school so early. But some of you reached out to me and realized, well, isn't this data that in a way is dependent on each other? Like this before number and this after number is the same person. So the 2 sets of data are not independent from one another, and that's kind of strange. So when I first presented this, I believe it was Monday or even last week, I forget now, I had just jumbled up the data, and I give you a random set of before numbers and a random set of after numbers. But it turns out everyone answered a before and an after. So we had this matching that was naturally happening between the 2 different sets of data. So I reorganized it. This is the same set of data from last time, but now I've matched up with the person. So that person who said before the closure of school they had a sleep score of 4, then said after they went to a 9, right? And that person. So it turns out we don't have 2 independent sets of data. Sure, that 4 is independent of that 6, that 9 is independent of that 8, and so on and so forth. But they're dependent on each other in this direction because that's the same person. It's like person 1 had that same score, right? Person 4, 5, 6 had that same score, right? So there's new ideas about what happens when we have data that appears to be 2 samples, 2 different sets of data, but it turns out they're dependent on each other for some reason. They can be matched up in a meaningful way, which usually happens when it's the same person that is doing like a before treatment and an after treatment or so on and so forth. Or maybe if you're doing an experiment with sets of twins, then the fact that those 2 people are like genetically matched might make for a matched pairs test instead of a 2-sample t-test. And the big difference is, again, when we did a 2-sample test, we were checking what might the true difference in averages were, right? So we did an average before, an average after, and then compared those differences. But now in a matched pairs test, you actually find the differences from each group. So in my case, I'm going to do after minus before. Not that it matters, but again, I was thinking that the after would be a bigger number. So just to keep everything in the positive, again, not that it had to be, I was thinking I'll do bigger numbers minus smaller numbers. So I'm going to be subtracting. That was a difference of 5, a difference of 2. Oh, that was a difference of -2, right? That person actually slept worse after. Okay. So now we have this new set of data, this one set of data, that's the differences, and we want to question what might the true average difference be, rather than the true difference in averages. We had a similar situation arise with the slight play on words when we were doing sampling distribution or distribution of a sample, right? Those 2 things sound very similar, but they're very different. So again, a matched pairs test, the key ingredient is that we're going to be looking at what might the average difference be. So the null hypothesis is naturally that the true average difference is really 0. And the alternative, like always, is it going to be greater than, less than, or just not equal to? And I'll go with the true average difference. And again, in this case, I'm thinking that this is going to be a positive number. Okay. And then you pick your alpha level and do everything you're used to doing, but you do basically a 1-sample t-test. You're just doing a t-test on the differences, right? And then there's some conditions you have to check, and I have an attached set of notes attached to this assignment. So I just wanted to take a few minutes to, again, just say hello, give you a chance to physically kind of like see me and see what's going on. But matched pairs is really the new big idea. And it's chapter 25 in the textbook if you want to read it, or just read through the notes. It should be pretty self-explanatory. It ends up being a one sample t-test, right? So just a t-test on the differences, and that's the big difference. So hopefully that makes sense. Hear from you soon. Thanks.